Hello and welcome to the physics lab. Today we're going to talk about Ohm's law. Now, before I start, do you know what an ohm is? Oh yeah, sure, I forgot this is a video. Ohm is where the art is. Okay, that was a really bad joke. But you should have come to expect that by now. Now there's something that you should know before we start this lab. I'm not wearing any pants. Alright, now, what I'm going to explain first, but you thought I was talking about, you didn't realize I was wearing shorts? Okay, come on over here, I'll show you what equipment we're going to need for the lab. The first thing we're going to need is this power supply. Alright? To plug it in, you need the cable that goes with it. It'll probably be right on top or nearby in a box. You'll need a Logger Pro, which I'm sure you're all familiar with from 20L or other classes. You will need a bag like this, and in this bag there is a current probe and a voltage probe. Now if you remember, in the previous lab we used a multimeter to measure voltage, and we could also use this to measure current, but you know what, we're not going to use this today. We're going to use this instead. Alright, so don't worry about that. You are going to need one of these prototype boards. Now, we may use something different during the lab, but it's going to be essentially the same. If we're using one of these plastic ones like that, you need two of these. And what these do is they fit into, put them in the right direction, into the prototype board. You will need 3 cables. Pick number 3, my lord. Alright. 3 cables. I prefer using 2 red and 1 black, but the color doesn't really matter. Electricity conducts just fine no matter what the color is. Just a little bit easier to keep track of. It's for your sake, not mine. You're going to need 2 resistors. There are going to be boxes of resistors. Get 2 different resistors. If you get 2 of the same, well, there's not much point in doing the second one. And you'll need a light bulb and a light bulb holder. Now they may be separated, but I'm sure that all of you can put a light bulb into a light bulb socket. Might be a little hard. I'm having a tough time. I'm sure you can handle it. Maybe take 2 or 3 tries. Alright, so we're all ready to do the lab, right? So let's come on over here and let's actually do the lab. How we set it up. Now come on over here on this side so you can see the computer too. You can be able to see the computer. Okay, so what we have here is we have our power supply. I already plugged it in, and I plugged in the Logger Pro, and I plugged in the USB. You should know how to do that already, so I'm not going to go belabor that point. Now we want to run the circuit. We're going to bring it out here, and then we want to go through the current probe. Through the current probe, not across the current probe. And you see there's even an arrow that says the electricity is going through the current probe. That's going to be important next lab, but just remember it for now. And then we'll put one of our resistors in here. I've got a 100 ohm resistor. We put it in there. Make sure that you actually get it through both of them. I missed on this one. And that's actually something that happens quite a bit. People get no current no matter what voltage they turn it to, and they wonder why. It's because this has got to be through both of these slits, like here. If it's off one of them, you don't have a good circuit, and you get 0 voltage. And then we go back to the minus. Alright, so now we have to hook up the voltage probe. The voltage probe, we want to measure the voltage across the resistor. Alright, that's because we're trying to figure out how many ohms there are. I had the wrong edge. Alright. Now, because of the way I got this set up, it makes the color a little bit easier. And I'm going to put the red probe on here and the black probe on this other side, on the black one. Now, what would happen if I got those reversed? It'd blow up! You're just going to get a negative number instead, and you know just to switch it back and forth. Not a big deal. It's measuring voltage, you really can't break anything. It's when you measure current that you got problems. So that's why you gotta make sure you did it just the way I did. You have the wire running from the plus to the current probe, red, and then from the black of the current probe over to here. All right? Very important. Now the problem is we've got these two ends here that are supposed to go to the Logger Pro. Where do we hook them up to? Well, I can tell you, because I've already done this lab, that the voltage is going to have to be hooked up to channel 1. See, like that? And then the current will have to be hooked up to channel 2. Now, how do you know you did that right? Besides the beeping noise, which is always fun to hear. Well, if you hooked it up to the wrong side, you're going to find it very difficult to fit it in. It will fit, but you'll have to force it, and that's probably not optimal use of the equipment, so don't do that, all right? So remember, voltage, which is this one, goes to channel 1, and current goes to channel 2. So we're almost all set to start taking data. All right, so how do we do this? Well, this is pretty straightforward, actually. I loaded up the Logger Pro file so that you don't have to do that either. I mean, you don't have to watch me do that, but you'll have to do that on your own. Now, you notice that we've got this collect button here. That means that it's actually working. It's connected. If you don't see this, if you don't see green lights on here, you got some problem with your Logger Pro. All right? Remember, there should be 4 wires connected to the Logger Pro. The USB, the power, and the voltage and current probes. If you have less than 4, or more than 4, you have a problem. Yes, you do. And psychotherapy will not help. That's a different problem. All right. So, if we wanted to take data, what have we forgotten to do? Do you know what we've forgotten to do? Oh, we forgot to turn the power on. Okay. Now again, if you remember from last week, I told you to put the current output current right about at noon here. We'll do that again. Now, what you're going to see here is as you turn the turn the voltage up, the current is going to change as well. That's good. We want that to happen. But we don't want to go above 6.25 volts. Do you know why? Because these probes for voltage don't work above 6.25 volts. So you want to keep it below 6.25. And we'll see what happens when you don't listen to me in a minute. Alright, so what voltages do we want? It doesn't really matter. We're just going to cover about 10 points between 0 and 6.25 volts. And what you do is you hit the collect button on here. And then when you do, you'll see this keep button comes up. And what happens is, if you look at the red dot here, that's the point we're at right now. If I change the voltage, you see the current moves up. I mean, the dot moves up. It's actually at a not a very good scale right now because the current is going from 0 to 5, but we'll figure that out in just a minute here. And what we do is when we get to a point that we like, we hit the keep button and it'll stay there. So let's just keep this one right here. Let's turn the voltage all the way down to 0 or so. And let's hit a keep so we get one that's close to 0. And then we'll turn it up to about a volt or so. If I can do that. That's good, right there. 1 volt. And we'll hit keep. Again. And as you can see here, something's wrong because there's just 1 point on there. What happened? Well, over here we have 2 points, so why are there only 1 point? Well, let's auto-scale the data and see if it looks any better when we auto-scale it. Oh, there's 2 points. We just couldn't see them before. There's 3, actually, because, oh, that's the one that's current, that's drifting right now. All right, so we'll go up a little higher. We'll go up to 2 volts or so. And it's off the scale, so we can't see it. And we'll hit keep again. And then we'll auto-scale it again. And now we've got 3 points. And they're all in a line. This is good. I'm going to skip ahead to 6 volts just so I can get the scaling right. Alright, that's about 6, maybe a little bit more than 6, but that's okay. And we hit keep. And then we auto-scale it again. And we got all these points in a row. So then we can take a couple in between. I'll take, say, around 5. You see it's showing what the value is right there all the time. And let's just take one at 4. I'm only going to take a couple more. And we'll take one at 3. Look at that, they're all in a row. Isn't that nice? Now, what we're interested in here, well, let's find out first, what happens when you go above 6.25? See, the thing is, the equipment here can go above 6.25, but the measurement will go up to 7 volts. The measurement equipment can't. So it's still pegged at 6.25. So then when I take a data point, look what happens. And then I auto scale it. It's over there. And if I go up to 8 volts, it's still saying 6.25. And see, it just flattens out. So anything above 6.25, it just says it's 6.25. So let's turn it back down and take a look at what we have. One thing that you got to be careful of is these resistors can get hot if you leave them on too long. So don't leave them on too long. What we're interested in here now is Ohm's law says that the resistance is futile. Oh wait, no, that was Star Trek. Ohm's law says that resistance is equal to what? Do you remember? It's voltage over current. Well, we could take individual points and figure, okay, for this one here, the voltage is this, the current is this, and divide it. Or we could just use algebra. Because all we have to do is take all these points here like this, select them like that, and then do a curve fit, a linear fit, on Logger Pro. But it says waiting. Why is it waiting? Because it doesn't think we're done taking data. So we have to hit stop. And it tells us that our slope is 97.2 V over A, voltage over current. That's an ohm. Alright? Now what is this particular one? Just kidding. This one here, if you look at it closely, says it's 100 ohms. And we got 97.2. So that means it's pretty good, right? Yeah, probably. Now it helps if you put it back in the way. There we go. See, even I do it wrong. Good amount of the time. Alright, and so then what we do is we take our data and we're going to put it into the Excel spreadsheet. And this is the Excel spreadsheet. Resistor 1, we said it was 100 ohms. And then ask for a tolerance. Some of these have tolerance listed on them. And if they do, you write down the tolerance. Otherwise, you assume it's 10%. So I type in, because it's not written on this one, I type in 10. And then, very important, you don't write the percent sign. If you do, I'll get annoyed with you. Because what it does is it changes the format on that particular Excel cell. Don't do that. Then we're just going to type in the voltage and currents that we set here in our Logger profile. So we have them all listed right here. And in fact, let me see if we can do this. I'm going to see if I can cheat here with Excel. I'm going to open up a separate sheet. And I'm going to paste it there. Ooh, it did work. Okay. I could just go straight to here and type it in right there. Ooh, look at that. Now it took all my 6.25s too, so we don't want those, so we'll just get rid of those. Alright. And then we get, so now we've got the voltage. Now we'll get the currents except for those last two. Alright. So now we want to plot here with the trend line and formula. Why do I want you to do this if you've already done the plot in Logger Pro? Well, pretty much because it's a way to remind you of how to use Excel, since this is the second lab of the semester only, to draw lines, trend lines, and so forth. So let's do that. We do a insert, scatter plot, do the first one. And I forgot to start over again. Let me select the data first this time. Now we do a insert, scatter plot, and there's the data. Now according to, we says resistor 1 plot here with trend line and formula. So we put it over there. Let's move over just a bit. Well, so delete the legend. We want to put in the trend line in the formula. So you right click on one of the data points, add trend line. We'll make it linear. We want to display the equation on the chart. We don't want r squared. I don't know why people always do that. All right, and what it says is that y is equal to 0.10103. Why is that? That's wrong. On the other one we got 97. Why do we get 0.0103 on this one? Do you know? It's because we mixed up the x and y axis. So let's try this again. Let's delete this. And I might fix this next time so that the x and y axis are reversed on here. I don't know. It depends on how nice I'm feeling. So probably not. So now what you have to do is, let's just select one of them. Doesn't really matter which, I don't think. Page layout, oh sorry, no. Insert, scatter, and the voltages are all over the place. Then what you have to do is you have to find a white space on the plot, right click, hit select data, and then you're going to pick series 1 and we'll edit it, and the x values will come from the current just like on Logger Pro, and the y values will come from the voltage, which actually it already is. Did I get that right? I hope so. Let's see. Let's compare it with Logger Pro. Yeah, Logger Pro is the current and the voltage. Want to make sure those are the same. Alright, and you hit OK. And we hit OK again. Get rid of that. I hate those little legends. And now, when we add a trend line and we display the equation on the chart, we get y is equal to 97.202 x minus next to nothing. And if we compare that with our Logger Pro one, 97.20, basically the same thing. So what do we have to do now? Well, what's y and what's x? Well, y is voltage, so we should change this to voltage. Here's a tip. Don't edit your formula until you're sure all your data is right, because if you change your data, all right, before you edit the formula, it'll update the formula. But once you start typing in the formula like this, that's it. It won't. You'll have to delete the trend line and re-add it. And then, now this is voltage is equal to 97.202 times current. Current would be I, but I looks a lot like 1. So let's just make it current, like that. Now we should also add x-axis and y-axis labels and a chart label. Then we put it right here, and we're done with that one. Now we do the same thing for the second resistor. In this case, I'd get a 470 ohm one. We do the whole thing all over again, exact same way. We're not going to do it for the video. That'd be pointless. All right, and then we go and we fill out our form here. The form here says, what's the slope? What's the intercept for each of those? You can read it right off of your chart. You should read it right off of your chart. The measured resistance, what is that? That's going to be the same number as your slope. Okay? And then ask for percent difference. Well, how do we figure that out? Well, there'll be a formula right here telling you how to figure it out and telling you to delete it when it's done. Use the formula I give you. Don't make up your own formula. That's always a bad idea. But you're trying to compare your measured resistance to the resistor value that you're given here. Like if this one says 470 ohms and you measure 467. You want to figure out the percent difference between those. Okay, now it's asking, do these resistors follow Ohm's law? Well, you should be able to answer that by now yourself for both of the resistors. The second question is, are they within tolerance? Well, if we're assuming it's, in this case with the 100 ohm one, it's within 10%, that's 90 to 110, and we got 97. So yes, it is within tolerance. All right, so are we done? Not quite. We got a little bit more to do, but this is easy now. We're going to do the same thing, but this time we're not going to use a resistor. We're going to use that light bulb. Okay? So we're going to take the resistor out and do the light bulb. And we're going to see if it follows Ohm's law. Because basically what Ohm's law is saying is that line is going to be straight. And what you're going to find is that the light bulb maybe is a little bit different. And if I can find the parts, we're going to try something else. Actually, then we're going to go back to the resistor. We're going to take it out. And we're going to flip it around. So now it looks like it's upside down. Just one of the resistors. And then I want you to measure the resistance all over again. Sounds pretty straightforward, right? Should be. Finally, if I can find the parts, we're going to use something else, measure something else called a diode. All right, a diode is an interesting thing because I can tell you right now, it doesn't follow Ohm's law. All right? So, on the diode, and on both of these, what you're going to, on the resistor and the diode in this part 3, where you reverse the current, what you could do is you could take some data with it in one direction. Okay, so let's put it back the way it originally was. And you just take a couple data points, 3 or 4, say at 1, 2, 3, 4 volts, and then you flip it around, which would be the equivalent of -1, -2, -3, and so forth volts. You put your plot in there. It's not going to show up in Logger Pro anymore, being the same way, because Logger Pro doesn't care that you flip the resistor. All right? And you have a forward, you'll just have one plot going positive and negative. All right? Then you do the same thing with the diode, which might even be a special kind of diode called an LED, for light emitting diode. Yes, you may have heard of those before. I gotta see if I can find the parts though. Alright, so the important things are, don't go above 6.25 volts, make sure you have your things hooked up right, and get out of here as fast as you can, because I don't want to hang around with you guys anymore. Alright? What? You think I like it here? Physics lab, come on. Okay, so the next important thing to remember is the secret password. What should we have for a secret password? I think it should be pumpernickel. All right? Now don't tell anybody. And I'll see you in the physics lab.